All right, good morning, everyone. This is week 6, and we are on classwork 15 honors, solving exponential equations. So the objective is that students will be able to solve exponential equations using properties of logarithms. So what I want you to do is start with the do now and pause the video, take a second to try this on your own. Okay, so hopefully you've tried this by now, and there's actually 2 correct ways to do this. There's probably more, but based on what we've done in the past, there are 2 ways to do this. Okay, so I'm going to write the problem again so that we can go over both ways. So the first way would be to look at this and say, okay, this is a base 2, right? So we're looking at the base of the exponent, base 2 to the t. So then we would be using the logarithm base 2 and taking the logarithm base 2 of both sides, right? And then in this case, when we take the log base 2 of 2 to the t, our t comes to the front and the log base 2 of 2 remains. If we rewrite this like this, and then log base 2 of 2, 2 to what power equals 2 is just 1. So we get t equals the log base 2 of 10. And this is totally fine. Now the only thing is, if we do it like this, and I say, okay, I need your answer to be in a decimal, what we have to do is use the change of base formula in order to get a decimal. Because when we look at our calculator, and I'm going to pull up my calculator on my phone real quick. If I look at the calculator and I look for the log button, there's only log base 10. See that right there next to the 4? There's only log base 10, so I can't do log base, oops, I'm supposed to put a number first. So if I put 10 in here, right, I press log 10, I get 1. Now, I know the log base 2 of 10 is not going to be 1, because 2 to what power would be 10? It wouldn't be 1, right? We know that 2 to the first power is 2, so log base 2 of 2 is 1. Okay, so what we have to do here is use our change of base formula, which would give us t equals the log of 10 divided by the log of 2, okay? So what we do on our calculator then is we would do 10 log is 1, we already did that, and then we would do 2 log, which is 0.3010. Oh, that is a mess. But then I would divide 1 by 0.3010, and I would get t equals 3.322, which, if we think about it, should make sense, because I'm thinking 2 to what power is 10, right? I know 2 to the third power is 8, and 2 to the fourth power is 16, so 10 is somewhere between 8 and 16, so 3.322 makes sense. So that's one way we could do this, and I wanted to show you again the change of base formula that we did back when we were still in school. Okay, so if you need more help with that, I'll link a video to Khan Academy on change of base. All right, the other way that we can solve this equation, instead of taking the log base 2 of both sides, we can just use the common logarithm log base 10 of both sides, right? 2 to the t, log base 10 of 10, right? So really, I don't have to write the 10 here. If I just wrote log, we would know there's an invisible 10 because that's the common logarithm. But I'm going to keep it there just so we're clear. So I get 2 times the log base 10 of 2 equals, and the log base 10 of 10 I know is going to be 1, right? Okay, so then I can do t equals, to get t by itself, I'm going to divide both sides by log base 10 of 2. So then I'm going to move this down. T equals 1 over the log base 10 of 2. Okay, so that answer is also correct, but I know I can put that in my calculator to get a decimal answer. So hopefully you got either log base 10 over log 2 or 1 over log base 10 2 when you did this on your own. So then this extra step, I'm going to calculate log base 10 of 2. So I'm putting in 2 into my calculator, and then I'm touching the log base 10 button. So I get 1 over 0.3010, just like I did when we did it this way, right? So we should be getting the same answer, and we do, right? So this is two different ways to get the same answer, right? So the reason we're reviewing this, all this, is because what we're going to do today is solve exponential equations just like this, but we're going to do that within the word problem context that we were using in last week's lessons, okay? So let's jump in with the examples. You're going to have to remember all those formulas from last week, so have those handy or we'll review them. Either way, it's fine. Okay, so for example number 1, Dwight has $4,000 that he wants to invest in a retirement account. The account earns 8% per year. How many years will it take for Dwight to have $8,000 in the account? Okay, so what are they asking? They're asking for how many years. So our unknown value is, when we think of years, we always think T for time, right? Okay, so then we have $4,000. The account earns 8% per year. And then we also have $8,000. Okay, so first we need to figure out what formula is this, right? And remember, we have 3 options for formulas. Okay, so we have F equals P times 1 plus R to the T. This is our just regular percent rate of change formula. Then we have our compound interest formula, where N is the number of compounding periods per year. And then we have our continuous compound interest formula, or PERT. So I need to figure out which one of these formulas are we going to use here. So it says he wants to invest in a retirement account, earns 8% per year. How many years will it take? So I'm not seeing anything about compounding, right? It seems like we're compounding once per year, which we could use this formula and say, okay, once per year, how many years are in a year is 1. So really, if we had an n value of 1, r divided by 1 is just r, and 1 times t is just t. So I can just use my first percent rate of change formula. So I'm going to write this in. F equals P times 1 plus R over T. And let's fill in what we already know, okay? So F is our final value, right? P is our initial investment. R is our rate, and T is our time. So let's see what $4,000. So Dwight has $4,000. He wants to invest it. Then the account earns 8% per year. 8%, that's the easy one, okay? We know that's R. Every time we see a percentage, we're like, okay, that's R, and then we divide by 100, right? So my R value is going to be 8 over 100, or 0.08, okay? And then how many years, T? We don't know the years, okay? So we know that's going to be T. Will it take for Dwight to have $8,000 in the account? So it seems like if I've got my final value, my initial value, we're starting with 4,000, we're going to end with 8,000. So 4,000 will be P, and my 8,000 will be F. So if I substitute all these values in, I get 8,000 equals 4,000 times 1 plus 0.08 to the T. And we want to figure out how many years. So we're solving for T. And I think we can do that here, right? So if I first simplify wherever I can, I'm going to end up adding 1 plus 1.08 to get 1.08 to the T. And now I have an exponential expression. Okay? So I can solve this using my properties of logarithms. Now, since I have 4,000 times 1.08 to the t, I'm going to want to isolate this exponential expression first. So I want to divide both sides by 4,000 so that this exponential expression is isolated. So then I have 2,000, because 8,000 divided by 4,000 is not 2,000. 2 equals 1.08 to the t. Okay, so now I have 2 equals 1.08 to the t, and just like in the do now, I can take the log of both sides, right? So if I take the log base 10 of both sides, I could take the log base 1.08, but that's a little bit trickier because we would have to use the change of base formula, and log base 10 just seems nicer, right? So I'm going to take the log base 10 of both sides. And by all means, you can do that if you want and see if you get the same thing. You will. But I'm going to use the log base 10 because it's a little bit more efficient, of 1.08 to the t. Okay, so then I'll get log base 10 of 2 equals t times the log base 10 of 1.08, right? Remember, I call that the slide to the front. That t comes to the front, whatever the exponent is. And really the parentheses should have been on the outside like this. Okay, then to get t by itself, I'm going to divide both sides by the log base 10 of 1.08. So I will get t equals the log base 10 of 2 over the log base 10 of 1.08. And I'm going to use my calculator to actually compute that value because we want to know the exact number of years, right? So I'm going to say, okay, my first input is 2, and then I'm going to say log 10. So that's 0.3010, and then I have 1.08, and I'm going to hit log base 10. I have 0.0334. And if I do 0.3010 divided by 0.0334, my t is about 9.01, which I'm going to round to 9 years, okay, or 9.01 years. So what we found out is that it will take Dwight 9 years to have to make $4,000, $8,000 with an 8% interest rate per year. Okay, so we're using our formulas from last week, and then we're using our properties of logarithms from back when we were in-person school to solve this exponential equation, or this exponential equation, which became this exponential equation. We took the log of both sides and isolated our variable. All right, let's try another one. Okay, this one's a little different. Pam is using a savings account that has an interest rate of 3.2% compounded every month. If Pam has $5,000 in the account after 6 years, how much money did she initially deposit? Okay, so they're asking us how much money did she initially deposit. An initial deposit, what variable is that? Initial deposit. That should be our P value, okay? Now I want to figure out which one of these top 3 formulas are we using, right? So remember, we have percent rate of change, compound interest, and continuously compounding interest. When I read this problem, I see compounded every month. If we're compounding in a certain period, that means we're using our compound interest formula. Okay, so I'm going to write that in. F equals P times 1 plus R over N to the NT. And I want to fill in whatever I can here. I'm going to substitute in for each of these values. So I'm going to circle my numbers in the problem. Use a different color. So 3.2%, every time we see percent, that's usually our R value, right? And then we have $5,000 in the account after 6 years. Okay, so, and how much money did she initially deposit? P. So we don't know P, and we have $5,000 after 6 years. So that seems like $5,000 is our final value, F. And 6 years, of course, is T, time, right? So I can substitute in those values right now. So we're going to have $5,000 equals P times 1 plus my rate. Remember, we always would do 3.2 divided by 100, which would be 0.032. And then my T is 6 years. Now I need to figure out my N value, right? So when we have compound interest, we're going to look at how often we're compounding. So compounded every month. That means my compounding period is 1 month. So then my N value would be how many months fit into 1 year, right? So if 1 year is 12 months, and we have a compounding period of 1 month, that means there are 12 months in a year, right? So we have 12 as our N value. So I'm going to substitute 12 in wherever I see an N. And now I only have one variable, P. So this is good. So I've substituted in my final amount of money, my rate, my N value, and my time of 6 years. And now I can solve for the initial deposit. So let's use order of operations and simplify wherever we can. Okay, so 5,000 won't change. And then P, and then I'm going to say, okay, 1 plus 0.032 over 12. So I really need to do 0.032 divided by 12. And that's going to be 1 plus 0.0027. Oof. And then 12 times 6, I can do that. And 12 times 6 is, 12 times 5 is 60, 12 times 6 is 32. Okay, 72. I wrote 72. I meant 72. All right, so then I can do, okay, I can have 5,000 equals P times 1.0027 to the 72nd power. So I'm going to take my 1.0027, and I've kept it the long version in my calculator just so I have the most exact answer, and I'm going to put this to the 72nd power. Okay, so then I get 5,000 equals P times 1.21136. Approximately, I'm rounding. Okay, so now to solve for P, all I have to do is divide both sides by 1.21136. Okay, so I'm going to do 5,000 divided by 1.11236. Awesome. And I get that P equals $4,494 and about 95 cents. So maybe she really put in $4,495 and we have a rounding error, but whatever you put in the Google form, as long as you're close enough when you're doing the classwork, I will be counting that as correct. Okay? So if you have any questions, rewatch that bit, and then we can also text me or anything if you need any help. Okay? Good luck with the classwork, and I will see you next time.